Good afternoon, everyone. I am Dr. Rakhi, Assistant Professor, Department of Physics, Bethune College, Kolkata. I express my sincere gratitude to respected Principal Madam, Bethune College, convener and members of IQAC, Bethune College, Srijoni Moitro and Abhishek De from Department of Computer Science, Bethune College, all the listeners and technical support staff for giving me the opportunity to deliver Tuesday lecture for the month February 2022. Today I will talk on climate change, its impact on tropical cyclone and thunderstorm. During last 2 years, COVID-19 is a violent threat that has almost stopped the progress of human civilization. But parallelly, there is another threat that is silently killing our ecosystem. That is climate change and global warming. It will directly hit global economy and lead to loss in GDP. It is now one of the major issues throughout the globe. All first world countries already started major investment in coping up with climate change. More and more research opportunities have been developed throughout the world. Even Nobel Prize Committee also decided to give Physics Nobel for climate researchers. In 2021, Physics Nobel Prize was awarded to Professor Sukuro Manabe and Klaus Hasselmann for their modeling of Earth climate and predicting global warming. This has never happened before. Climatology is now a hot research topic. It is an interdisciplinary subject which can be a career opportunity for students of all basic science departments like physics, chemistry, maths, computer science, geography, environmental science, etc. United Nations has created an intergovernmental panel named IPCC for assessing the science related to climate change. So I thought climate change will be the best topic to discuss here. Global warming. This is a serious issue worldwide. In the year 2100, the global temperature will rise by 1.5 to 2 degrees Celsius. The maximum daily temperature may even rise from 4 to 6 degrees Celsius. The pollution level is increasing day by day. Today, average air quality index is 350 in Kolkata, which is very dangerous for health. During lockdown last year, we have seen air quality index below 50, which is a very healthy sign, and it resulted clear starry sky and clear distinct visibility. Recently, we have faced many weather hazards like rain in Greenland. Islands of Greenland near North Pole faced first time rain in history in August 2021. This is alarming. Glaciers are melting, sea level is increasing, and we are recently facing extreme rainfall or drought conditions throughout the world. Oceans are getting acidified due to increasing level of carbon dioxide concentration. Due to all topics are equally important to discuss, but due to time limit, today I will discuss only two topics, tropical cyclone and thunderstorm, and I will affect their change with climate change. First one is tropical cyclone. Let us discuss how tropical cyclone is formed. Tropical cyclone is a rapidly rotating storm originated at deep ocean. When warm sea water at temperature around 26.5 degrees Celsius hits moist air and it moves upward and creates low pressure below. The cloud moves above 10 to 12 kilometers and gains sufficient energy. This void below draws nearby winds. Due to the Earth rotation, wind moves right side in the northern hemisphere and left side in the southern hemisphere. This effect is called Coriolis effect as shown in the figure right side. So wind moving from opposite direction comes to fill up the void below center and creates eye of the cyclone as described in the figure left hand side. This figure is an infrared map of cyclone Taute taken from Wikipedia. In different regions across the globe, cyclone is popular in different names. In Indian Ocean and South Pacific, it is named as cyclones. And in Eastern North Pacific and Northern Atlantic Basin, its name is hurricane. And it is named as typhoon in Western North Pacific. But all are same type of storm. Severity of cyclone is determined by different parameters like speed, track shape and sinuosity, landfall, length, energy metric, damage profile, etc. Category of cyclone according to speed is mentioned in the table right hand side. According to the table, cyclone velocity greater than 165 km per hour is named as extremely severe cyclonic storm, and greater than 220 km per hour is named as super cyclonic storm. For example, our recent cyclone Amphan is named as super cyclonic storm as its velocity was 240 km per hour. This speed mentioned here varies at different position as well as different height. So the speed mentioned in the table are during their landfall, that is when the cyclone hits ground. Each cyclone follows its own track whose curvature is measured by its sinuosity. Its track length varies from few hundred to few thousand kilometers. Role of sea surface temperature SST. Sea surface temperature is very important in determining the cyclone intensity. The threshold temperature for cyclone formation is 26 to 27 degrees Celsius. But the average sea surface temperature variation is 0.4 degree to 2 degrees Celsius. But sometimes, like during cyclone Phony, SST temperature raised to 31 to 32 degrees Celsius. Increasing sea surface temperature leads to increase in moisture content and enthalpy flux, resulting high intensity and rainfall during cyclone. The graph right hand side shows that cyclone power increases with increasing sea surface temperature, especially greater than 28 degrees Celsius. Variation with ENSO cycle. East Central Equatorial Pacific Ocean periodically goes through warm and cool phases due to ocean current. This happens due to interaction between surface and atmosphere. The warm phase is named as El Nino and La Nina is the cool phase. The whole cycle is named as ENSO, El Nino Southern Oscillation. The cycle can continue for few years, consisting of 3 steps: El Nino stage, La Nina stage, and neutral stage. Its effect in cyclone is different in different ocean. The frequency of tropical cyclone is generally higher during El Nino, the warm phase of Pacific. Tropical cyclone frequency and track also depends on monsoon and post-monsoon seasonal variation. Research in Bay of Bengal shows that cyclone frequency is higher in post-monsoon, that is October to December, than pre-monsoon June to September, and pre-monsoon March to May, and June to September monsoon seasonal variations as shown in the table below. Pre-monsoon tropical cyclones took the northward track and made their landfall across the coasts of Bangladesh and Myanmar as shown in green color in the map right hand side, and post-monsoon tropical cyclones made their landfall directly on the coasts of Orissa and West Bengal as shown in pink color in the map. Alarming threat is that cyclone frequencies are increasing. Increasing temperature by 0.5 degrees Celsius, sea level increased by 10 centimeter. It follows high probability of storm and flood. Therefore, most of the weather hazards occurred in last decade than previous ones. Australian tropic faced maximum rainfall over last 2 millennium. The graph right hand side shows that number of reported disasters per decade is very high in last decade. So we must analyze atmospheric data to predict cyclone and its path. Cyclone forecast is also extremely important. The journey of cyclone forecasting started by Colorado State University in 1984. It was a statistical model. Method improved when dynamical model came into picture in 1997. Most recent model was published in 2014. It is a hybrid model consisting of high resolution satellite data. It offers high degree of accuracy. 12 institutions from 4 continents across the globe pioneer cyclone prediction today. Among them, Colorado State University, National Oceanic and Atmospheric Administration, Tropical Storm Risk, UK Meteorological Office, Australian Bureau of Meteorology and University of Melbourne, City University of Hong Kong, Hong Kong Observatory, European Centre for Medium Range Weather Forecast are very important because their data is publicly available at their websites. And the rest institutions, Geophysical Fluid Dynamical Laboratory, Japan Meteorological Agency, Shanghai Typhoon Institute of China Meteorological Administration, National Typhoon Center and Korea Meteorological Administration provides data only to member countries, commercial users, etc. These institutions can be a career opportunity for PhD and postdoc for our students. There are few web-based servers like windy.com which provide real-time location during cyclone. The diagram shows the real path of cyclone Fani. The server can predict landfall from 120 hours to 12 hours in advance with sufficient accuracy. Research shows that accuracy in landfall prediction is better than accuracy in rainfall prediction. The diagram is taken during cyclone Fani, where a total track of cyclone I is shown clearly. Our next topic is lightning and thunder, a potential weather hazard. Climate change may be sparking more lightning across the world, and there is an increasing scientific evidence. Each year, number of each year number and frequency of lightning is increasing and creating more and more accidents. Research show that around 12% increase in lightning are happening for each 1 degree Celsius temperature increase. Between April 2020 and March 2021, over 18.5 million lightning strikes were recorded in India, and between April 2019 and March 2020, lightning incident has been increased by 34%. Let us discuss how lightning and thunderstorm are formed. All of us know that lightning is caused by cloud electrostatic charge. It happens at a height of 20,000 to 60,000 feet, where cloud cools to freezing temperature and ice crystals form. Polar ice molecule collides with each other to create charge, which are separated by turbulence in air. Lighter positive charge grows upward and heavier negative charge between becomes at the downward. It creates potential difference greater than 10 million volt. When sufficiently ionized, spark is produced, it named as lightning. Lightning creates around 27,000 degrees Celsius, which is 6 times hotter than the sun surface. But thunder is a different thing. Lightning and thunder are different things. During lightning, air is heated and expanded suddenly. It causes explosion in air. The shock wave caused by the explosion manifests as a large booming sound. It is named as thunder. So thunder sound is heard few seconds later than the lightning. Most of this lightning occurs at high atmosphere. Its name is intra-cloud lightning. And few of them, approximately one third, falls to earth. Its name is cloud to ground. This causes hazard to us. Thunderstorm intensity and frequency are highly dependent on convective available potential energy. Study shows that lightning radiance increases with increasing convective available potential energy, in short form CAPE. As shown in the graph right hand side, it shows that lightning radiance increases with convective available potential energy. Another parameter that is equally important is deep atmospheric shear, which helps development and intensity of thunderstorm. With global warming, research shows a positive change in CAPE but negative change in tropospheric shear. But the increase in tropospheric shear will dominate over decrease in CAP will dominate over decrease in tropospheric shear. Therefore, the thunderstorm will be more frequent. Flash rate increases with increasing pollution. Thunderstorm flash rate is highly dependent on pollution level measured by SPM, suspended particulate matter level, that as dust, fume, mist, etc. High SPM means higher pollution level. SPM concentration greater than 240 microgram per meter cube contributes a high amount of lightning flash rate. Lightning also depends on convective condensation level, in short form CCL. Low CCL value means the cloud base formation is very near to ground and surface pollutants are easily available to get injected into the cloud with the help of strong wind flow. It is found that high SPM value and CCL value, both high and low, lightning flash rate and wind speed of thunderstorm reaches its maximum value as shown in the figure right hand side. In this figure, high flash rate is denoted by red color, whereas a low flash rate is denoted by green color. Thunderstorm produces nitrogen dioxide which mixes at the troposphere. It is found that the troposphere contains more nitrogen in lightning days than without lightning days. The data was collected in April and May at Kolkata because in April, May, due to northwester, thunderstorm is maximum. Further, oxides of nitrogen and sulfur are also considered important for lightning frequency. Oxides of nitrogen and sulfur concentrations are found to be higher level, that is sulfur oxide concentration 80 microgram per meter cube and nitrogen oxide concentration 8.5 microgram per meter cube. During pre-monsoon thunderstorm and lightning activity, it happens. So increasing surface pollution near storm environment can increase in lightning flash rate during thunderstorms. Graph shows that for high sulfur oxide and high nitrogen oxide concentration, flash rate increased. It is shown by red color at the top. Detection of lightning and thunderstorm is very important. Let us discuss few lightning detection techniques in Asia recently. Lightning discharges produce broadband electromagnetic radiation ranging from few hertz to several gigahertz. Very high frequency interferometers, very high frequency time of arrival systems, and low frequency time of arrival systems are used to detect lightning location using radio waves. Recently, phased array radar system, in short PAR, that uses rapid scanning technology with radar remote sensing is used. These are used to observe fast evolving storm structures and analyze their relationship with lightning activities. More recently, Osaka University, Japan has designed broadband observation network for lightning and thunderstorm, in short BOLT, that uses low frequency signal for 3D lightning location mapping. The figure is for a standalone thunderstorm sensor made by BIRL.com. There is a popular slogan, when thunder roars, go indoors. The figure shows that the world lightning map created by NASA's lightning imaging sensor from satellite data taken between 1995 to 2002. Lightning density per year has been shown in color plot. Red color for maximum lightning prone region, while the blue color is for less lightning prone regions. It is clear that the northern part of India, specifically our Bengal, is at a high risk zone for lightning because high pollution, humidity and temperature level creates the atmosphere more conducting and suitable for thunderstorm. Recently, research is going on how to harvest the energy of thunderstorm and for future use. So this is not our this is a separate topic to discuss and not in our scope of today's lecture. I have discussed how increase in temperature and pollution level directly affect tropical cyclone and thunderstorm. There are more such climate parameters which are responsible to maintain our ecosystem. For example, fire in Amazon rainforest is the greatest example. 95% species in world's largest greenery are in danger. Many of the species has already extinct and rest are in danger. So robust goal must be taken for species in the post 2020 global diversity framework. Otherwise আনন্দবাজারীয় ভাষায় বলা যায় শেষে সেদিন আর বেশি দূরে নেই। পৃথিবীতে শুরু হয়েছে ষষ্ঠ গণবিলুপ্তির পর্ব। নমস্কার।